3 times in my life, I had the opportunity to understand what the near-term future of hardware was. Beginning of SAP, 3270, the first real good online terminal of IBM. Then, when the mainframes became, from a footprint of this screen here, much smaller to a size of this desk here. The third was when network computing a la Sun became available for us in commercial applications. And the fourth time is now. This is a CPU on the right-hand side. This is a CPU with 4 cores. The CPUs hit a wall 1982. The clock rate of CPUs cannot be increased anymore. The clock rate is around 3 gigahertz. And this CPU frequency is pretty much a limit, a technical limit. Has to do with the speed of light, has to do with the size of molecules. But Moore's law, the famous guy from Intel, everything doubles every 18 months, speed, capacity, etc., will continue. How? The computer architects invented multi-core CPUs. So one CPU, one central processing unit, has, in this case, 4 little assistants. And the assistants can't do everything, can't make every decision a CPU can make, but can tremendously help to process data. That means we have to figure out, with our software, how we keep the CPU and the 4 assistants busy. This is not that easy. The term is called parallelization or concurrency. In the computer science world, it is clear that this is the real buzzword because it's reality. It's a concept which is there, and we still have to exploit it. The developers of commercial applications come a little bit late. The gaming software is there. Other software vendors are exploiting this technology already. The enterprise software manufacturers have to follow. So parallel computing is the key. Think about that this is only the beginning. I'm pretty sure that we will see something like a CPU with 8 cores, probably this year, next year. The industry watchers will tell you exactly what the prognosis is, what the large chip manufacturer or CPU manufacturers will deliver. My prediction is, my personal prediction, but it's just based on Googling, we will have soon on one board 8 CPUs, and each CPU will have 16 cores. We do the little math. This is 128 computing units on one board. One board called one blade. If you take 10 of these blades, this is already 1,280. If we take 100 blades, still not much money. Little money, but not much money. We have 12,800 computing units. This is the future. I do not believe that the future for future software is to make software just cheaper, the total cost of ownership lower, run in the cloud, have less operational costs, less maintenance costs, etc. That's all good. And many people are working on this and have to do this. Actually, this is more for the real companies. That is not so enticing for young students in the university. They are more looking into the future. So let's look into the future. This is actually one of these boards here. Thanks to a well-known CPU manufacturer. This is one blade. I got the price. It's really cheap, $6,300. Without memory. We need a little bit memory, so then it will get, the price will get significantly higher. This thing can hold 144 gigabytes. When we started R3, a computer with half a gig was the biggest we could get. Actually, the ones who are as old as I am, IBM had to change first from 24-bit address to 32-bit address. To address beyond. Now we have a direct access space you can buy today of 144 gig. I predict this will be within Moore's time. This is 18 months. Half a terabyte, 500 gigabyte. So if this is the horizon, somebody has to start thinking. And we started actually a while ago at the University Institute. And thanks to SAP, we got future software which was under development to work with that. This was the on-demand system, business by design. And there was the under development, database under development, T-Rex. And that really caught fire. If we can use these large number of computers, if we can get computers which are so relatively speaking cheap, a computer with something between 10 and 100 blades, thousands of little computing units, and a memory which is far beyond what we have seen in the recent past, what we have just seen in the last 2 years, probably ramping up. We could build systems in the inner core completely differently. Knowing how the computer works, we can build the application differently. At the university, you cannot build an application of the size what SAP has. That's impossible. There's, I think the team which built Business by Design worked several years, and there were more than 1,000 people working on the project. But if you get a system to change a part of the system, this is possible. So we concentrated on changing the data management part. And we found some interesting things. The first one is we decided, basically in a brainstorming session based on design thinking, we should move away from record storage to columnar storage. So what is that? I have to explain this. We still do relational databases. We cannot change this. This is the nucleus, basically, of all commercial applications today. Just to do a quick explanation what columnar storage is. On the left side, we have a table with 4 rows and 4 fields. The traditional storage is we store them record by record by record in a sequence. And when we need a new block, then we start a new block. And when we have no space in memory anymore, then we go to disk. All your data today is on disk. And when the programs are accessing the data, it comes into memory. And in order to make it faster, with the help of the Oracle database, or the IBM database, or the Microsoft database, or our own database, the database system keeps information in memory, and the application does the same. So we call this caching, and that makes our systems relatively fast.